Hello students, welcome. In this session, we will see examples based on dice probability. Alright, we all must have seen a dice. Yes, on one dice, if we see there are 6 faces onto that dice. Yes, and all the 6 faces are denoted by the numbers 1, 2, 3, 4, 5 and 6. Yes, and whenever we are rolling a dice, we can get only one number out of these 6 numbers on the top of that dice. Now, based on this experiment, we will see few examples. The first example is a die is rolled when find the probability that an even number is obtained and second odd number is obtained. For this experiment, the experiment here is a dice is rolled. The sample space for this would be on this dice, as we have known that there will be 6 faces, and on the 6 faces we will have the numbers 1, 2, 5 and 6 labeled on each of them. So this will be our all possible outcomes whenever a dice is rolled. All of these possible outcomes taken together in one set makes our sample space for this particular experiment. Now let's talk about which probability we have to find out. The first is an even number is obtained. Alright, so our event is, let E be the event, an even number is obtained. Out of all the 6 possibilities, we want only those possibilities which are even numbers. 1 is not a possibility, 2 is a possibility, 3 is an odd number, so not a possibility, 4 is yes even number, 5 not a possibility, and 6 is your even numbers. So here we will have 2, 4 and 6 as the even numbers out of all the possible outcomes. So the probability of obtaining an even number is, the formula that we have is number of favorable outcomes divided by the total possible outcomes. Favorable outcomes, from this we know that n of e, as there are 3 and for sample space n of s total 6. So this would be 3 by 6, reducing it by 3 we get the answer as 1 by 2. So my probability of obtaining an even number is 1 by 2. Now for the second one, we have to find out the probability that an odd number is obtained. Let O be the event that an odd number is obtained. The sample space that we have is 1, 2, 3, 4, 5 and 6. Out of the sample space, I want only those possibilities where the number is odd. Just now in the last example that we have seen for even numbers, now we want only those numbers which are odd. So that is 1, 3 and 5. This would be my event. So n of odd numbers would be 3, and again the probability of obtaining the odd number is 3 by 6. After reducing it by 3, we get the answer as 1 by 2. Now let's take a look at the second example. What is the probability of getting a number less than or equal to 6 when a dice is rolled? Whenever a dice is rolled, we know that a sample space would be all the possible outcomes taken together. Possible outcomes as in, on the dice there are only 6 faces, and on the 6 faces we have the numbers 1, 2, 3, 4, 5 and 6 labeled on them. Now we want to find out the probability of getting a number less than or equal to 6. Alright, a number less than or equal to 6. Out of them, how many numbers are there less than or equal to? Equal to as in we can include the number 6 also. So all the numbers, if we observe here, these numbers are less than 6 or equal to 6. There is no number greater than 6. So here n of b is equal to 6, and same our n of a sample space is also 6. So the probability of obtaining a number less than or equal to 6 is number of favorable outcomes divided by total number, which is equal to 1. Look into the third example. Two dice are tossed. The probability that the total score is a prime number. Now here in the last example we have talked about when a single dice is tossed. When single dice is tossed, we can look only one number which is present on the top of that dice. In this experiment, we have two dice to be tossed. So for two of them, this will be my two dice. We have to find out the sample space first of all when two dice are tossed. When two dice are tossed, this is my dice number 1 and this is my second dice. Suppose on the first dice I have the number 1 into this, and on the second dice I can have all the 6 numbers into it, which is 1, 2, 3, 4, 5, 6, 5 and 6. Alright, any of the 6 numbers. Yes, so this 1 will pair up with 1, 2, 3, 4, 5 and 6. Yes, so if we look here, that is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5 and 1, 6. Similarly, in the same way, if on the first dice I have the number 2, this number 2 will pair with each and every of the 6 possible outcomes. The first would be 1, which is 2, 1, then 2, 2, then I have 2, 3, 2, 4, 5 and 6. Yes. Now, just now we have seen that for there is one possibility 1, 2, and if I have another possibility is 2, 1. Both of these two possibilities are completely different from each other. You cannot consider them as one. Why? Because here the order is important. Order as in here for the first one, on the first dice we have the number 1 and on the second dice we have the number 2. And here we have a vice versa for that. So the order matters whether that number is appearing on the first dice or on the second dice. In this way, if we look up to all the possibilities, each of the 6 numbers will pair with each of the 6 other numbers, right? So the total number of sample space would be this, and that is total 36 sample space. All right. Now, from this total outcomes, we want to find out probability of the event that the sum is prime. Sum is prime as in, if we are looking into each of the outcomes, there are two numbers into this one. First number is from the first dice and the second number is from the second dice. Addition of both of them should be a prime numbers. Yes, addition of both of them. Suppose the first I have is 1, 1. So addition of both of them, 1 plus 1 equal to 2. This sum should be a prime number. Yes, this is what we want to check. Now what do we mean by first of all a prime number? Prime number is any number which is divisible by 1 and itself, which is divisible by 1 and itself. So let's see how many prime numbers we will have. 1 is neither a prime nor a composite. We have 2, 3, 5, 7, 8 and 9 not a prime because they are divisible, right? 10 again not, 11, 13, yes, this would be my prime numbers. We have so on and so forth, but we want to check addition of this. The highest number on the coin is, on the dice is 6. So if I add them together, which is 12. So I'm not getting any sums greater than 12. So we will keep for now prime numbers till 13. Let's check all those all those outcomes where their addition is prime numbers, which means out of these 6 numbers. 1, 1 is a possibility. The addition is 2. Here the addition is 3. For this one 5, 1, 6, 2, 1, so on and so forth. Addition of both the numbers should be a prime number. Alright. So in this way, the number of points, total number in this event E is 15. So the probability here would be number of favorable outcomes divided by 36. After reducing it, we get it as 5 by 12. Yes. Now, for the next example, again, we have the same experiment that the two dice are thrown simultaneously. What is the probability of getting two numbers whose product is even? Alright, same sample space for two dice thrown. So here also, the sample space, the total number of sample points into this one would be 36. Each one number, there will be on the dice one, I have this 6 numbers. This is my possibility, and for the second dice also I will have the same possibilities. So each of this number will get paired up with all the other 6 numbers. Each number will get paired up with all the other 6 numbers. In this way we will have our sample space, and the sample point, that is number of sample space, would be 36. Now let A be the event of getting two numbers whose product is even. Alright, we want to find out only those two numbers whose product is even. Alright, which means if I have the first possibility 1, 2, multiplication of these two, which is 1 into 2 equal to 2. This is an even number, so this is one of my favorable outcomes. Similarly, if 1, 2 is a possibility, then obviously 2, 1 would also be a possibility. Again, 2 into 1 would be equal to 2, so even number. In this way, if we go on checking for each of all the possibilities, 36 possibilities, we have these many 24 possibilities here where the two numbers whose sum is even. So when we are finding the probability, that is the total number of favorable outcomes, 24 divided by 36. Reducing it by 12, we get the answer as 2 by 3. Now let's give a look into the last example. Two dice are thrown together. What is the probability that the number obtained on one of the dice is the multiple of number obtained on the other dice? Here the experiment is same, that the two dice are thrown together. And we want to find out the probability that number obtained on one of the dice is the multiple of number obtained on the other dice. The sample space for two dice thrown would be this, and the number of sample points here is 36. We want to find out only those possible outcomes, where the number obtained on one dice. Here they have not given any order. Do they want it on the first dice or they want it on the second dice? No, they are just talking about one number. Suppose x comma y if I'm taking, then out of this two, either x or either y, out of this two, one should be the multiple of the other one. If I'm talking about x should be the multiple of y or y should be the multiple of x. We want to find out only those possibilities. The first possibilities, if we look here, is First of all, if we take the same numbers into them, 1, 1, 2, 2, 3, 3, 4, 4, 5, and 6, 6. Alright, these 6 numbers are multiples of each other. Yes. So there are total 6 possibilities for this one. For the second one, if I'm checking 2, 1, 1, 2, 1, 4. 1, if I'm taking the number 1, 1 and the other is 2. 1 will always be the multiple of the any other number. So 1, 2, 2, 1. Same 1, 3, 3, 1, 1, 4, 4, 1, 1, 5, 5, 1, 1, 6 and 6, 1. So that would be total 10 possibilities. Yes. Then next is, let's give it into the look. Next, if I'm checking, there is 2, 4. For 2, 4, yes, 1 is the multiple of another. Consider this one. 2, 5, we cannot. 2, 6, yes, can be considered. Next, I can consider 3, 6. Then I can also consider 4, 2. Then we can consider 4, 4 we have already here. 4, 6. Then next any another. Yes, we can consider 6, 2. And then last 6, 6 we have already there. So this would be total again 6. So addition of all of them together is my favorable outcomes, which is 22. So the probability is number of favorable outcomes divided by the total number of outcomes. That is, after reduction, I have it as 11 by 18. I hope this is clear with you all.